In this series, we're going to take a look at unsupervised learning. Now remember, supervised learning is things like regression analysis with linear or logistic regression, where we have a set of features and we're looking for a target. On the other hand, with unsupervised learning, we have features but no target. So we have the X, but we don't know the Y. Now, supervised learning is great, but the data can be expensive to obtain. And what if the data set's huge? What if it's millions of rows? Might not be so efficient with supervised learning. But with unsupervised learning, it's good for handling a large set of data and also good for grouping or aggregating data when we don't quite know what it is we're trying to achieve. So the result is that our data will be grouped into two or more clusters, and those clusters might have something in common. We might be able to label the clusters or see some similarities among cluster members. So k-means is an analysis that we're going to do, which is a cluster of points, and k-centroids, where k is some integer larger than 0. So, larger than 1 rather. So with k-means, what we're going to do is look at different Ohio counties based on certain data sets, like the household income, the graduation percent, rural percent, and we're going to see how we can group Ohio counties together. This will give us a lot of benefits because we know that the needs of an urban county are different from the needs of a suburban county, which is different from the needs of a rural county. But even within those divisions, we can look at rural counties that have higher average income, lower unemployment, higher graduation rate, compare those to sibling counties that look very similar but with lower metrics and say, okay, what factors might have helped one county be more successful in those metrics than the other, and how can we share those metrics from one county to the other? So what we tend to want with clustering is similar points in the same cluster and dissimilar points in different clusters. So cluster is defined by the centroid, which is the average point in the cluster, the average of all of its members. K-means indicates that we're going to have k-centroids, or effectively one centroid for each cluster. And so each row in a data set will be assigned to one and only one centroid. We wouldn't have it be the group of more than one cluster. So the goal is to minimize the distance or loss functions from the points to the centroids. And we get to pick the loss function, but it's typically Euclidean distance, where if we have a series of distances to measure, we'll square them, sum them, and then square root that entire unit, and that will give us the Euclidean distance. So how do we judge success? Well, we look at inertia. We can look at an elbow diagram for that, which is the distance within cluster, the average distance between members within a cluster or from members to their centroid. We can also look at how far the centroid points are in a cluster, and generally smaller is better. Now, could we have a cluster with inertia of 0? We could if all the cluster points happen to be at the same spot, or if it was a cluster with only one member. With only one member, the member itself is the centroid because we don't need to look at distances among cluster members if there is indeed only one member. So what we'll typically do is we'll train a model. We'll use something like k-means, decide on a loss function, and then we'll guess the initial value of the centroids. After that, we iterate. So we say, okay, what's the loss function from each row to the closest centroid? And then if the sum of the loss functions is the same or doesn't change significantly, we're good. But if the loss function is larger than we want, then we'll move the centroids and then we'll repeat the loop. And we'll keep repeating this loop until we get a loss function that is acceptable. So that's typically how we'll train a clustering model. So in this series, we're going to take a look at k-means. We're also going to take a look at k-nearest neighbors, which is where we throw members on a scatter plot and then add new members and look at the nearest neighbors and see if we can make some assumptions based on that. We'll also look at some distance metrics and some hierarchical clustering with dendrograms. So several different techniques we'll take a look at in this series. I hope you like it. Thank you.